So let us start with the today's topic of discussion. Hello, am I audible to everyone?
Yes, sir, you are audible.
Okay, so in the today's
Yes,
class,
sir.
we will be talking about different addressing modes that are being used in our AVR microcontroller, and we will at an end we will be looking into the auto increment and auto decrement kind of an instructions that are only available in our AVR microcontroller. Finally, we will be looking into a simple example that can help us to understand this pointer as well as the auto increment and auto decrement kind of an instructions. Okay, so let us start with today's discussion of different type of addressing modes that are available in our AVR microcontroller. Okay, so I'm going to share my screen with you and let me know whether the shared screen is visible to everyone or not. Is the shared screen visible to everyone, my friends?
Yes, sir.
Okay. So we are basically having two type of addressing mode. One we called it as a register addressing mode, and another we called it as a direct addressing mode. Okay. So this type of addressing mode will help us to understand that which instructions can be used with which particular memory section of our AVR, and in that memory section which particular registers or which particular part of that memory section can be used to be accessed. Okay, so addressing mode is nothing but it is all about accessing the data from the memory. So there are different way we can access the data from the memory, that is through the different type of an addressing modes. Okay, so a CPU can access a data in various way. So that is what we started with the discussion of that. It is all about that how we are accessing a data from a memory. The data could be in the register or in the memory or provide an immediate value. So there are different way the data can be there. The data can either be in a register, the data can either be in a memory, or it can be any immediate value, that means any constant value. Okay, so the various way of accessing a data, the data in register, memory, or in the immediate value, that are referred as addressing mode. Okay, so the AVR provide total, okay, there is a mistake. So there is actually 13 distinct addressing modes which are available in our AVR. Okay, so it is just I have written one, but there are 13 different distinct addressing modes which can be categorized into the following different groups. Okay, so this different addressing modes can be categorized into different six ways. Okay, that is a single register, or we can call it as an immediate value to be accessed. The other is register to register, other is direct, other is register indirect, third is a flash direct, and finally is a flash indirect. Okay, so these are the different categories in which all the 13 distinct addressing modes of an AVR can be categorized. Okay, so they are single register, register, direct, register direct, flash direct, and flash indirect. Okay. Let us try to discuss all the addressing modes one by one. So first addressing mode, we call it as a single register addressing mode. It is also called as an immediate mode. Okay, so in which we can have only a single address, or sorry, a single register, or it may be a case that there can be an immediate values. Okay, so in this addressing mode, the register. So in single address, we can have an operand as register. So for an example, already we have talked about NEG and COM. Okay, so can anyone tell me that what is NEG all about? For what purpose we can use this NEG instruction? Okay, I will try, like to listen it from roll number 59. Hello, 59 number. Can you tell me for what purpose we are using NEG instruction? Yes, 59 NEG instruction. For what
Yes,
is
sir.
it is meant for? Yeah, so any instruction for what purpose it is meant for? Hello.
Hello, sir.
Yes.
So
59.
I'm not in the question. Can you repeat the question?
NEGR18. Suppose if I'll write this instruction, then what the AVR is going to do? Yes, 43 number. Hello, 43 number. Hello, 43 number.
Yes, sir.
Yes, can you tell me what for what purpose we use NEG instruction? NEG? Anyone in the class having an idea about NEG instruction or COM instruction? We have already
Sir,
talked
it
about this. Yes, 27?
it reverses the sign of the value. For example, negative to positive, it makes a positive
No,
to
no,
negative.
actually, negation, yes. So actually, it is not the case that what you are telling. Actually, it is going to do the two's complement of the given data in R18. Okay, because in AVR we generally used to have two's complement to implement the negative numbers. Okay, so energy instruction will give you the two's complement of a register. Okay, so whatever the content in your R18 is, the two's complement of R18 would be stored in the R18 itself. Okay, and COM instruction, yeah, it is little slightly different than NAG instruction, so it will be taking one's complement of the register. Okay, so these are the two example of a single register addressing mode. If I talk about an immediate, okay, we are having an immediate value that 0 cross 25 is an immediate value. Same way SUBI, we have talked about this SUBI sub with borrow instruction. So this is the immediate value which would be subtracted from your R8. Okay, so the constant value is sometimes referred to be an immediate data since the operand comes immediately after the opcode when the instruction is assembled. Okay, so it is the case that when this particular instruction would be assembled, the this value will comes immediately after the opcode of this. So that's why we can call it as an immediate values. Okay, so the AVR refers this mode as a subset of single register addressing mode. So this is single addressing register mode. This is single address immediate register addressing mode. Okay, so this is actually the subset of the single addressing mode. Okay, so this addressing mode can be used to load the data into any of the R1 R16 to R31 general purpose register. Okay, so this you need to remember that this single address, sorry, single register immediate addressing mode, it can only be used with your register that is R16 to R31 only. We cannot use it with the different registers such as R that this single address immediate single register immediate addressing mode that can be used for a register in between R16 to R31. The other we can have a big category of direct addressing mode. Okay, so in this we are having two instructions. Okay, LDS and STS. Direct addressing mode means you can directly give the value of an address. Okay, in the mode, the operand data is in the RAM memory location, okay, whose address is known, and this address is given as a part of an instruction. So if I want to access a data from, let's say, 560 address, okay, if it is in RAM, I can use this addressing mode, direct addressing mode. And two instruction we already talked about, LDS and STS. Okay, so contrast that with an immediate addressing mode in which the operand data itself is provided with the instruction. So In the previous case, we have seen that the operand itself was provided as a data. Okay, but in this case, it is address which is provided as an operand in the instruction. Okay, so we are having LDS R19 0 plus 560, with which the data of your location 560 would be loaded into R19, and same way we are having an STS instruction where the data of an R19 is stored into the memory location. So it must be noted that the data memory does not supports the immediate addressing mode. Okay, so if I talk about a RAM section, the RAM section is not supporting the immediate addressing mode. Okay, so RAM section always supports the direct addressing mode. In another word, to move data into an internal RAM or an IO register, we must first move it to the general purpose register, and then we can move it from general purpose register to the data memory space using the STS instruction. Okay, so it is the case that if you want to access your data memory section, that is the ROM of your AVR, then you need to rely upon the direct addressing mode, and these are the two instructions which will be used in the direct addressing mode. Okay, I hope I'm clear. Yes. Hello. Hello friends, am I clear to you? Hello.
Yes, sir.
Yes, sir.
Let's move further. The other is what we called it as an IO direct addressing mode. Okay. So in IO direct addressing mode, we would be, so in the previous case, that is direct addressing mode, we can access the whole RAM section. Okay, because we already talked about that LDS and STS. These are the instructions that can be used to access the whole RAM section of your AVR. But if my access is limited up to the IO section of the AVR, then we can have an IO direct addressing mode, in which we can access the IO section. IO section already we have talked about that the section of a RAM whose address is from 3F to 5F, sorry, 20 to 3F. Okay, these are the what we called it as an IO section of the RAM. Okay, so to access the IO register, that we called it as an a special function register, we need to use a special mode, that is what we called it as an IO direct addressing mode. Okay, so in this IO direct addressing mode, the addressing mode can be addressed only in the standard IO registers. So already we have talked about 00 to 3F or 20 to 5F. Okay, so these are the special functions 664 registers. So if I want to access this, I can use two instruction, in instruction and out instruction. So in R18 0 cross 16, okay, so the 0 cross 16 is nothing but it is the location of pin B. Now I think all of you have you will be aware of what this Pnb register. So Pnb register is a register in which we would be looking for the data that is coming from coming into your microcontroller from the external world through port B. Okay, so its address is 0 cross 16. So this is an IO address. So IO address is different than the memory address. Okay, so this IO address, so either you can use this in R18 0 cross 16, which copies the content of R16, sorry, which copies the content of location 16 into R18 through pin B register, and the other is out 0 cross 15 R18 that will copy the content of R18 into port C register, because the location of port C is given by R15. So in the IO register, register can access by the names also. Okay, which is easier to remember, or through their address. So we are having both option. We can either use the address or we can use the name of the register. So in the above example, we can also write in R18 pin B, which is same as address of 0 cross 16, and we can also write out port C R18, which is having an address of 15. Okay, so this IO direct addressing mode, we are having two instruction, in out, and we can use either address or we can use the name of the register also. Okay, and that can be only possible if you use the include file, because in include all this pin B is defined as 16 in your .equ assembler directive. We already talked about it. And the other is register indirect addressing mode. Okay, so this is one of the most important addressing mode, because we know that pointers are the most important thing for any programming language. If we talk about programming in C, yes, pointers are most important because we can do anything with the help of one pointer. We can access the memory section dynamically with the help of the pointer. Okay, so all that thing can be categorized under the category of the register indirect addressing mode. Okay, so in the register indirect addressing mode, the register is used as to point the data memory location. Okay, so instead of directly using the memory location, okay, we can store that memory location into a register, and then the register can be used to point it out that particular memory location as if it is working as a pointer. So already we have talked about this thing in our 8085 also, that if we talk about HL pair, it can be used as a point. Okay, same way in our AVR we are having three registers. Okay, these registers are X, Y, and Z registers. All these three registers are 16-bit registers that will allow us to access the entire 536 byte of a data memory space in your AVR. Okay, so if you want to use a pointer, we can use our X, Y, and Z register that can be used as a pointer. So that was same case with our 8085. We are having BC, BE, and HL pair, which can be used for the pointing out purpose. It can be used with help of STA and STAX and LDX, that instruction. Same way we are having XYZ. These are the three pointer registers which are available in our AVR, and as it is 16-bit register, we can access the whole 65K of data memory space of an AVR. Okay, so where these registers are, so each of this register is made up of the combination of the two register in a general purpose section. Okay, so for an example, the combining value of 26 and 27 makes an X register. Okay, so X register can be made with the help of combination of R26 and R27. Same that was case with our 8085 also, that we use M register, and M register is made with the combination of H and L pair. Okay, so in same way we are having 26 and 27. Combining 26 and 27, we can make a register which is an X register. So in this case, 26 is the lower byte of an X, and 27 is the higher byte of an X. Looking the same way, we can have Y and Z register which are made with a combination of 29 and 28 and 31 and 30. Okay, so 26, 27, 28, 29, 30 and 31. Combining each two will make registers that are X, Y and Z register. Okay, so these registers are 16-bit registers. They are widely used as pointers. Okay, because the dynamic value can be we can change the value in XYZ register dynamically. Okay, so that can be used as a case of a pointer. We can use them with the LD instructions to read the value. So over here you can mark that the difference between LDS and LD instruction. So there is an instruction we call it as the LD instruction that can read the value from the location pointed out by the register. So I can use LDX, so that will copy the content of X into any of the general purpose register. So you can have LDR16X, so that will copy the content of memory location that is being pointed by X into R16. Okay, so basically that can be used for the pointer purpose. Okay, now we can have this ST instruction. So ST instruction can be used to write the value to the location which can be pointed out by any of the register, that is X, Y and Z register. Okay, so this is an example that how we can use this pointer. We can use LDIXL, or you can have LDIR26 also. Okay, because 26 is equivalently be treated as an XL, and XH would be equivalently treated as 27. Okay, so you can either use LDI R26 0 cross 30, or you can also use LDI XL 0 cross 30 and LDI XH 0 cross 01. Okay, so that will form an address which is 0130. Okay, so combination of XH and XL will make a address. Okay, one address. Okay, and I can use LDR18X, so that will copy the content of location 0 cross 130 to your R18 register. Okay, same way you can have ST instruction. So same is being done with an Z register, that LDI ZL 9F, LDI ZH 0 cross 13. So the address that is being formed with your HL and sorry ZH and ZL, that is 139F, and ST that will store the content of R23 into the location pointed out by your Z register, that is exactly 139F. So if you'll investigate after executing this code, now you will find it out the value of R23 would be stored into the memory location, that is 139F. Okay, so what are the advantages of this register indirect addressing mode? So one of the advantage of register indirect addressing mode is that it may access the data dynamically rather than the static execution. Okay, so if I'll use direct addressing mode, okay, I can access the data statically, means that will become static. You cannot change the address. But yes, if you want to do that thing dynamically, yes, you can use the register indirect addressing mode. Then there is another addressing mode that we called it as an auto increment and auto decrement in the register indirect addressing mode. So this is actually the subset of your register indirect addressing mode, in which you can have auto increment or auto decrement options for the pointers. Okay. Now the 16-bit registers that are X, Y, and Z, they can go from let's say location 0000 to FFFF. Okay, which covers the entire 64 kilo memory space of an AVR. Okay, now if I want to store the data, okay, I can use my increment instructions. So using an INC, that is increment ZL instructions, to increment the pointer can cause the problem when the address is, let's say, 5FF. Okay, so when your ZL is incremented, it won't be going to 6000, it will go to 5000. Okay, so the instruction INC ZL will not propagate a carry into ZH register. Okay, so in the AVR gives an option of an auto increment and auto decrement for the pointer registers to overcome this particular problem. So if I want to access the memory in sequence, okay, so I need to use my increment instruction. Okay, so already we have seen that thing in our 8085 also, that we can have two different type of instruction, INR and INX. Okay, so that is also the same case over here, that we are also having an auto increment. So we can say that if I'll use INR instruction, which is in this case INC instruction, then there will not be a carry that would be propagating from your lower byte to the higher byte. Okay, so to solve this particular problem in AVR, we use auto increment and auto decrement kind of an instruction. To solve that problem in our 8085, we were having an another instruction, INX instruction, instead of INR instruction. But in case of this, we are having an auto increment and auto decrement kind of an instructions, which affects the entire 16-bit of a pointer and has no effect on the status register. Now also you need to take care about that whenever you are using auto increment or auto decrement instructions, it is not going to affect your status register. Means, let's say that if you use INCZL, and if the value of ZL is 00, and if you sorry FF, and if you use INC ZL, then it will become 00, it will roll over and it will affect your status register. But if you're using an auto increment instructions, then status register will not be affected. For an example, if the pointer registers goes from FFFF to 000, it will not raise any kind of a flag. So if you will be using INC or another instruction, it would be raising a zero flag. But in this case, if you use an auto increment auto decrement kind of an instruction, it will not raise any kind of flag because it is not going to affect your status register. Okay, so these are some of the example, these are some of the auto increment and auto decrement kind of an instruction. Okay, so you can easily see that there are three different registers we are having: X, Y and Z. In total we can have 14 different instructions that can be used with this pointer. So let us go through all these instructions one by one. So the first instruction is LDRN, and RN means any general purpose register. You can use 1 to 31, any value you can use as an N. Okay, so LD, any register with X, after loading the location pointed by X, the X stays the same. Okay, means it will load the value of value that is being stored in the memory pointed by your X, and the value of X will remain same. The other instruction is LDRN X plus. So after loading the location pointed by X, X is incremented. So it is combination of two instruction. Okay, that is LDRNX plus INCHL XL. Okay, so combining these two, you can have another instruction. So that is LDRNX plus. Okay, so what it will be doing is it will be loading the value pointed by X into your RN, and then the X would be incremented. The other is, so this is what we called it as a post increment. Okay, the other instruction is LDRN minus X. So what it will going to do is, first of all it will decrement the value of X, and then whatever the value pointed by your X would be loaded into your RN. So this is what we call it as a pre-decrement. So increment is post and decrement is pre. So that you need to remember that first of all it will decrement the value of X, and then it will load the content of memory location pointed by your X into your register. And in the previous case, first of all it will load the value and then it will increment. So that is what we call it as a post increment, and this is how we can call it as a pre decrement. Okay, so same three instruction you can see that is also going to work for your Y register. That means LD RNY will load the content of Y, and then the Y will remain same. Y plus, it will load the content of Y, and then Y will be incremented. Minus Y, that will decrement the value of Y, and then it will load the value of Y into your Rn. But there is another instruction. Okay, okay, so this instruction will load the value pointed by this offset, that is plus Q. So after loading the location pointed by Y plus Q, Y stays the same, means it is offset. Okay, so plus Q, it is your offset value. So any offset value you can give. Okay, and the offset value would be loaded into your RM. And same way the four instructions would be for your Z register, means LD RN Z, LD RN Z plus, LD RN minus Z. So it would be working same the way the all the LD instruction for X and Y are they working, means no increment, post increment and pre decrement. Okay, and it will also be working with the offset, means Z will remain same after the value pointed by your Z plus Q would be loaded into your register. Okay. So let us see one of an example which can be used to add the multi-byte data. Okay, location stored at the location. Okay, so this example says that I want to write down the program, assembly language program of an AVR to multiply. Okay, so no, it's not. Uh, Write an assembly language program to add two multi-byte number and store. They are stored at the location 130 and 133. Okay, and we need to add that two numbers. Okay, and store the result at the location 160 and 163. Okay, so we are having two multi-byte numbers that are stored at this memory location and this memory location, and we need to write an program to add these two numbers and store the result at this particular memory location. For an example, let's say 1, 2, 3, 4 byte number is being stored from location 130 to 133. So first 130 is stored, 132 is stored, 133 is stored. So there are 4 bytes that are stored at the location. Okay, and the other location 150 to 153, it is being stored with the memory with the value that is 29, 78, 74 and 2a. I want to add this to number and I want to store the result at 160 to 163. Okay, so how I can write the program? So I can count that how many number of bytes I need to add. So I need to exactly add 1, 2, 3, 4, 4 bytes. Okay, so what I'll be using is I'll be using one counter. Okay, that can count 4 for me. Okay, so the first line is very self-explanatory, that it is dot include m32df.inc, that will include your library file. Then I will load the counter value in my R16, and then I will start pointing out all the three arrays with xyz. So the first location is pointed by 130, so I will load that thing in my X. So LDI XL 030 and LDI XH 01. Same way, I will use Y register to point out this value. So LDI Y 050, LDI YH, that is 01. So it will, by the combination of YH and YL, you will be having 150 as being pointed out. And the third I will be using for storing the result, that is ZL 60 and ZH 16. Okay, so the combination of this will become 160. I will first of all clear the carry, because I'm going to use my ADC instruction rather than ADD instruction, because I want to add with carry. So before adding, so for the first time if I'm going for an adding, I'll be clearing that carry, and then I will go into the loop. So first of all I will load the content into my 18 register pointed by my X, and then it will increment the value. Second, I will load the value in R19 with pointed by Y, and then it will increment, and then I will add R18 and R19. I will store that value in my the added value into my location pointed by Z, and then it will be post incremented. I will decrement the value of 16, and I will repeat the same process 4 number of times. Okay, so this program will add the content pointed by 130, 150 and stored it at 160. Okay, so this is how we can use the different addressing mode, and these are the different addressing modes that are available in our AVR microcontroller. I hope I have made the things very clear. If you are having any kind of doubt, you are free to ask. Any doubts, my friend? Hello?
No, sir.
Okay, so if you are not having any kind of doubt, that is all from my side for today. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you so much.
Thank you, sir.